So here is another question on coplanar vectors. So it has been asked to show that the vectors a vector I cap plus 3j cap plus k cap, b vector is equal to 2I cap minus j cap minus k cap, and c vector, which is 7j cap plus 3k cap, they are coplanar. We have to show it. So we have to follow the definition, which means if the scalar triple product a vector, b vector, c vector, if the scalar triple product is equal to 0, then the vectors are coplanar. Okay, so in determinant form with their x, y and z components, we can write it as 1 3 1, then 2 minus 1 minus 1, then here it is 0 I cap 7 j cap 3 k cap, so 0 7 3 0 7 3. So this is equal to, if we go by 1 2 0 in the first column, so it will be 1 into minus 1 into 3 minus 1 into 7, then minus 2 into 3 into 3 minus 7 into 1, and 0 multiplied with whatever the result is, it will be 0. So no reason to do the calculations, leave it like that. So it will be 1 into minus 3 minus of minus 7, which is minus 3 plus 7, and here it is minus 2 into 9 minus 7. So this will be equal to 7 minus 3, 1 into 4 minus 2 into 2, which is equal to 4 minus 4, which is equal to 0. So as the scalar triple product it is equal to 0, it means the vectors are coplanar. Okay, so this is the thing. So here, in order to save time, you always should follow that column and that row where there is a 0 to save time, because the calculations will become short. Okay, so always use this trick. So here is another question on coplanar vectors. So here it has been asked to find the value of lambda so that the vectors a vector, which is 2I cap minus 3j cap plus k cap, then b vector, which is I cap plus 2j cap minus 3k cap, and c vector, which is j cap plus lambda k cap, they are coplanar. So again, the basic definition of coplanar vectors, which is the scalar triple product a vector, b vector, c vector, it should be equal to 0. So in determinant form, it is 2 minus 3 1, the x, y and z components of a, then 1 2 minus 3, then 0 1 and lambda. So this should be equal to 0. So they are coplanar. We have to find the value of lambda, which means the determinant is equal to 0. So we'll calculate it along the first column. So it will be 2 into 2 lambda minus of minus 3, which becomes 2 lambda plus 3, then minus 1 into minus 3 lambda minus 1 plus 0 with whatever the value it is, the result, it will be 0, so no need to calculate. That is equal to 0, the result is equal to 0. Okay, so that implies 4 lambda plus 6 plus 3 lambda plus 1, that is equal to 0. That implies 7 lambda plus 7, that is equal to 0. that implies lambda is equal to minus 7 by 7, which is equal to minus 1. So the value of lambda, so that these three vectors are coplanar, it is equal to minus 1. Okay, this is the value of lambda. So here is another question on coplanar vectors. So it is given that the vectors 2i cap minus 4j cap plus 5k cap, I cap minus lambda j cap plus k cap, and 3i cap plus 2j cap minus 8k cap, they are coplanar. We have to find the value of lambda. So again, basic definition: if this is a vector, this is b vector, and this is c vector, okay, then the basic definition is that the scalar triple product, if that is equal to 0, then they are coplanar. So here it is given that they are coplanar, so in determinant form it becomes 2 minus 4 5 1 minus lambda 1 3 2 minus 8. It is equal to 0. So that implies here anyway you can go, there is no 0, so we'll go by this first row. So it is 2 into minus lambda into minus 8, which is 8 lambda, minus 2 into 1 2, then minus of minus 4 into minus 8 minus 3, then plus 5 into 2 minus of minus 3 lambda, which is 2 plus 3 lambda. So that is equal to 0. That implies 16 lambda minus 4 plus 4 into minus 11, which is minus 44, plus 10 plus 15 lambda, that is equal to 0. That implies 16 plus 15, that is 31 lambda, minus 48 plus 10, that is minus 38, that is equal to 0. That implies lambda is equal to how much? 38 by 31. So if the value of lambda is 38 by 31, then it is coplanar. So for lambda is equal to 38 by 31, this three vectors, a vector, b vector, and c vector, they are coplanar vectors. Okay, so this is